This is SpaceTime Series 29, Episode 72, for broadcast on the 17th of June 2026. Coming up on SpaceTime, our ever-changing Milky Way Galaxy, how Jupiter may have helped start life on Earth, and astronauts aboard the International Space Station forced to prepare for emergency evacuation. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New observations are showing astronomers how our home galaxy, the Milky Way, is being slowly changed through its gravitational interactions with our nearby neighbouring dwarf galaxy, the Large Magellanic Cloud. Located 163,000 light-years away, the Large Magellanic Cloud is easily seen in the southern hemisphere skies. Data from both the Sloan Digital Sky Survey and the European Space Agency's Gaia spacecraft are showing how the Large Magellanic Cloud has begun to stretch and distort our Milky Way galaxy. Sloan's been surveying the skies since the year 2000, and Gaia's been mapping the position and motions of over 2 billion stars across the Milky Way and beyond since 2014. As we mentioned in last week's SpaceTime, a stream of gas and stars now connects both the large and small Magellanic Clouds with each other and with our own Milky Way galaxy. Now that's not surprising. Astronomers have long known that galaxies grow by merging or cannibalizing other galaxies. Not only can we see galactic collisions taking place in other galaxies, but when we study the orbital motions and chemical compositions of stars, you can determine their stories and their origins with remarkable accuracy. And it's shown us of a cataclysmic collision involving the Milky Way billions of years ago, which led to its current shape and structure. That ancient encounter left scars so deep that, billions of years later, they still define the galaxy itself. Now, the evidence for this ancient cosmic collision comes in the form of streams of stars within the galaxy that have unusual chemical compositions and are moving in strange orbits compared to the majority of the galaxy's stars. See, while the Milky Way's native stars travel mostly together, orbiting around the galactic centre, these, let's call them alien stars, travel at strange pathways, sliding past the native stars and moving in different directions. And many of these stars have lower metallicities than average stars born in the Milky Way. Metallicity refers to a star's chemical composition, as astronomers refer to all elements other than hydrogen and helium as metals. The lower metallicities in these alien stars suggest that they're less enriched with heavy elements compared to stars that were born in the Milky Way. Now, there are a number of these alien star groupings within our galaxy. The largest is known as the Gaia Sausage Enceladus. These are the fossil remains of a galaxy that collided with the Milky Way somewhere between 8 billion and 11 billion years ago. The term sausage refers to the pattern that stars make as they move across the sky. It was a collision which changed the very structure of the Milky Way. Stars from the Milky Way's original disk were splashed into the galaxy's halo, while new star clusters were captured. The cosmic encounter also changed the orientation of the Milky Way's disk and its alignment with its dark matter halo. Scientists have no idea what dark matter is. All they can tell you is that it's a mysterious invisible substance which interacts only gravitationally with normal matter. They also know that by mass, there's 5 times more dark matter than normal matter, but that's really about all they know. Based on how it's influencing the normal matter we can see, astronomers think dark matter forms a vast halo around the Milky Way. This halo is much larger than the luminous part of the galaxy that we see. This dark matter halo can be stretched out of shape by a major encounter, and its gravitational fingerprint suggests that's exactly what happened here in the Milky Way. The event was so big, no other cosmic encounter seems to have impacted the Milky Way quite as much. That is until now. And this is where the Large Magellanic Cloud comes in. It's slowly but persistently pulling the Milky Way apart, disturbing this dark matter halo again. In an echo of what happened with the Gaia Sausage Enceladus, the Milky Way is being drawn into an accelerating gravitational dance with the Large Magellanic Cloud, recoiling in response to its approach. The thing is, it's not the only encounter our Milky Way galaxy is facing. Another satellite, the Sagittarius Dwarf spheroidal galaxy, has already skewered through the Milky Way's disk several times, in each encounter having stars ripped off and devoured by our galaxy. and it will crash through the Milky Way's disk again in a few billion years' time. And speaking of time, in somewhere between 3.7 and 5 billion years from now, the Milky Way itself will be devoured by an even bigger member of our local galactic group, the giant Andromeda Galaxy M31. These are all signs that although they seem stable and permanent, galaxies are ever-changing, constantly evolving. This report from Durham University.
Galaxies are islands of stars scattered throughout the universe. We live on our own island, the galaxy we call the Milky Way. Scientists use computer simulations to understand what our home galaxy looks like today and the turbulent life it led. This computer simulation was built with some of the most advanced supercomputers in the world, including those at Durham University. Today, we'll be using it to go on a cosmic journey through space and time, travelling back to when the Milky Way was but a young infant galaxy. Let's jump back in time to a much younger universe, just 4 billion years after the Big Bang. Galaxies were much smaller back then and were packed closer together. They live inside big clouds of dark matter, a mysterious and invisible substance that makes up most of the matter in the universe. It is connected in a shape that looks like an intricate spider's web. This cosmic web, as it's called, forms the highways along which galaxies move and sometimes collide. An infant version of our Milky Way about 9 billion years ago, much smaller in size and much brighter, because it is vigorously forming new stars. This young Milky Way is about to undergo a massive collision with one of its neighbours, which will change it forever. This collision has been called the Gaia-Enceladus merger, and is thought to be the last significant collision that took place in the Milky Way's life. Let's now speed up time to get back to the present day. After the Gaia-Enceladus collision, the Milky Way grows and matures in solitude, and ends up being a beautiful barred spiral galaxy. Spiral galaxies are shaped like a dinner plate. They can look like a thin line or round, depending on the angle at which we look at them. Within the disk of the Milky Way, there are winding spiral arms, which are the birthplace of many new stars. In the centre, the stars form an elongated bar shape, which rotates in a rhythmic cosmic dance. And we are lucky enough to live on a planet that circles a star in the outskirts of the Milky Way, the galaxy we call home.
This is Space Time. Still to come, how Jupiter may have helped start life on Earth, and astronauts on the International Space Station forced to prepare for a potential emergency evacuation. All that and more still to come on Space Time. Okay, let's take a break from our show for a word from our sponsor, Incogni. If you're anything like me, you're probably concerned about your privacy online. And for good reason. Did you know there are hundreds of data brokers out there quietly collecting, buying and selling your personal information? Now, I'm talking about your phone number, your home address, your browsing habits, even your location history. And that's where Incogni comes in. Incogni is a service that acts on your behalf, requesting the removal of your personal data from these shady data brokers. And they don't just send a one-off email. They follow up, track responses, and ensure that your data actually does get deleted. Think of it as having a digital privacy agency constantly working for you behind the scenes. And the best part, it's all incredibly easy. You just sign up, give them the go-ahead, and Incogni take care of all the rest. And within just a few weeks, you'll start seeing the results. There'll be fewer spam calls, less targeted advertising, and a genuine sense of relief knowing that your private data is no longer being traded like a commodity. Now, as a Space-Time listener, we're offering you a special discount deal. Just go to incogni.com/StuartGary. That's incogni.com/StuartGary. And if you're not completely satisfied, no worries. Incogni offers a 30-day money-back guarantee, so you can try it out risk-free. You know, protecting your privacy really shouldn't be optional in this digital age. So let Incogni help you by keeping your personal information where it belongs, with you. That's incogni.com/Stuart Gary to access this exclusive discount offer and learn more. Stay safe, stay private with Incogni. A new study suggests our solar system's largest planet, Jupiter, may have provided some of the key ingredients which allow life to develop here on Earth. The findings, reported in the journal Science Advances, provides new details about how the early Earth may have acquired some of the elements necessary for planets to become habitable. The findings also suggest a new role for Jupiter in the distribution of these elements throughout the young solar system. The work's based on studies of the ratios of phosphorus to nitrogen in iron meteorites and in younger meteorites known as chondrites. Our solar system formed out of gas and dust that was swirling in a protoplanetary disk around the early nascent proto-sun more than 4.6 billion years ago. As these gases condensed into dust at different distances from the sun, rocks and ices would eventually form. These were the raw materials needed to form planets, moons, and ultimately life as we know it. Now, two elements of special importance for life are nitrogen and phosphorus. In the early stages of our solar system, gas and dust coalesced into bodies known as planetesimals. As these objects orbited the young sun in this chaotic environment, planetesimals collided, leaving shattered remains throughout the solar system. Eventually, many of these pieces were incorporated into planets and moons. Other pieces survive today's asteroids, still orbiting the sun and occasionally impacting the Earth as meteorites. And it's these meteorites which provide a window into the early solar system, back to a time before the Earth even existed. Chondrites and iron meteorites are two different classes of these messengers from space. As their name suggests, iron meteorites are dense metallic objects that are primarily made of an iron-nickel alloy. Chondrites, on the other hand, are stony objects, and they're responsible for most of the meteorites that have so far been found on Earth. Each type of meteorite originates from planetesimals that formed at different times in our solar system. The oldest generation of planetesimals are the source of iron meteorites. Chondrites, on the other hand, came from a second generation of planetesimals that formed some 2 to 3 million years later. Understanding how the Earth was made and the timing of its formation is important for astrobiologists who study how and when our planet became habitable for life as we know it. See, the young early Earth needed to have a supply of life's key ingredients. That includes nitrogen and phosphorus. There's long been debate between scientists over where Earth's stock of life essential elements came from. Some evidence points to chondrites in the outer solar system travelling inwards to arrive at Earth late in our planet's formation process. However, this new study is telling a different story. Using laboratory experiments and geochemical models, the study's authors reconstructed a map of phosphorus-nitrogen ratios across the early solar system. And they found differences between the first iron meteorites and the second chondrites generations of planetesimals. The experiments and subsequent geochemical modelling shows that the first generation had a higher ratio of phosphorus to nitrogen in the outer solar system, with that ratio decreasing towards the inner solar system. And this trend was reversed in the second generation of planetesimals, with higher phosphorus to nitrogen ratio in the inner solar system. The idea is that during the formation of the first generation of planetesimals, there was an outward flow of material that raised the phosphorus to nitrogen ratio in the outer solar system. And that's where Jupiter comes in. As the giant of the solar system formed and grew, the planet restricted the movements of phosphorus and nitrogen from the inner to outer solar system. And this meant that when the second generation of planetesimals appeared, those in the inner solar system were left with a higher phosphorus to nitrogen ratio than their cousins further out. The study's lead author, Rajiv Dasgupta from Rice University, says Jupiter's presence and growth history seems to have played a crucial role in determining the distribution of the basic chemical ingredients necessary for habitable worlds. It remains an open question whether a life-essential element budget similar to the Earth's can be established without a Jupiter-like planet in the population. And geochemical accretion models further show that Earth's present-day phosphorus to nitrogen ratio signature is best reproduced by the inner solar system's planetesimals, either those related to iron meteorites or those related to chondrites. So the study suggests that Earth acquired its inventory of life-essential elements, phosphorus and nitrogen, primarily from the inner solar system, without requiring any significant contribution from what was happening with the outer solar system's chondrites. This is space-time. Still to come, astronauts aboard the International Space Station ordered to prepare for an emergency evacuation. And later in the science report, a new study warns that global temperatures have now reached 1.37 degrees Celsius above pre-industrial levels. All that and more still to come on Space Time. Astronauts aboard the International Space Station have been ordered to prepare for an emergency evacuation of the orbiting outpost as cosmonauts began working to try and repair a growing series of leaks aboard the Russian Zvezda service module. One of the leaks, located in Zvezda's transfer tunnel known as the PRK, has gradually been getting worse ever since it first began venting atmosphere into space back in 2019. It's one of several leaks in the Russian segment of the space station, which have continued to provide concern for crew aboard the orbiting outpost. And it's prompted ongoing monitoring and repair efforts by the Russian Federal Space Agency Roscosmos. NASA and Roscosmos have been working together to try and identify the root cause, while Roscosmos has been applying leak mitigation measures, including temporary and permanent sealants. However, during the recent Progress 95 cargo spacecraft's operations, Roscosmos noticed an increase in the previous leak rate by about 2 pounds per day, and as a result, identified new suspected leak areas within the PRK. Following this observation, Roscosmos made the daring decision to begin work towards more extensive inspection and structural repair efforts. This revised approach involved cutting a bracket to better access an area identified as a possible leak source for further inspection. But that would involve using a method that could have resulted in elevated risk to the structure in that area. Instead of fixing the problem, it could have made the whole thing a lot worse. So in response, NASA directed the 4 SpaceX Crew 12 members, as well as NASA astronaut Chris Williams, who flew to the station aboard the Soyuz MS-28 spacecraft, to take a heightened safety posture, known as a safe haven, inside the SpaceX Dragon spacecraft during the procedure. The Dragon, you see, would act as a lifeboat in case an emergency evacuation was suddenly needed. However, eventually, Roscosmos decided against undertaking the structural repair work. Instead, they'd continue with their existing practice of simply adding temporary measurements and data assessments. These include a regular inspection of the suspected areas of interest and a review of areas where sealant was previously applied. Roscosmos says that during their inspection of the PRK, cosmonauts discovered 2 potential air leak sites. The first was sealed by applying the first layer of a 2-part sealant known as Gemetal 1, the standard go-to for leaking Russian spacecraft. The second site is located in a conical part of the PRK, and it's now also going to be treated with a sealant. The first modules of the International Space Station were placed in orbit way back in 1998. The 450-ton satellite, which orbits over 400 kilometres above the ground, has been continuously manned since the year 2000. But it's getting on in years, and NASA plans to retire the spacecraft in 2030 and then begin a deorbiting operation in 2031, eventually crashing the entire structure into the southeastern Pacific Ocean. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. Earth is now accumulating heat at an accelerating rate, with global warming last year reaching 1.37 degrees Celsius above pre-industrial levels. The new findings by the University of Leeds show strong and consistent evidence that the entire climate system is continuing to heat up, driving rapid global warming. The findings, reported in the journal Earth System Science Data, includes research from 56 different institutions across 17 countries and indicates that global warming will surpass the 1.5 degrees Celsius benchmark in about 4 years' time. The update also finds that 2025 global greenhouse gas emissions were at an all-time high, reaching some 56.8 billion tonnes of carbon dioxide, mainly from burning fossil fuels. Other findings show that 2025 was the third warmest year on record. 2024 remains the warmest. The World Meteorological Organization says China remains the world's biggest carbon dioxide polluter, producing a third of the world's total output, more than double the output of the United States and 5 times the output of India. A new AI study claims laser-powered engines could one day be supporting intelligent 6G networks. The findings, reported in the journal Nature, are based on the development of a laser-driven engine made from ceramic material that uses white light to move information over large distances. While conventional LED-based visible light communication systems typically operate over a few meters, the new photonic engine can move data more than 1.2 kilometers. The ceramic material used in the engine, which was produced by mixing calcium ions with chemical compounds used to make glass, was able to withstand far more power than other laser-based technologies. A new study has found that 13-year-olds who are given a smartphone are not any more likely to end up depressed or overweight, but they are more likely to get sleepy. The findings, reported in the Journal of the American Medical Association, found that while getting a smartphone doesn't seem to be linked to these issues, the amount of time they use it is. The authors looked into data from almost 2,000 teens who received a smartphone when they were 13, and they then followed their progress for a year. They found that having a smartphone was linked to insufficient sleep when the kids were 14. And it was the overall amount of time they spent on their smartphone, other than simply having a smartphone, that was linked to 3 key conditions: depression, obesity, and not enough sleep. Computer tablet sales have jumped by some 10% over the past year, and the devices themselves are continuing to improve, largely due to both AI and the cloud. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
The global tablet market continued recovery in 2025, with shipments rising 9.8%. This was year-on-year to 162 million units, according to research firm Omdia. And in the holiday quarter, momentum was strongest. The Q4 shipments reached 44 million units, so that's pretty good. I mean, tablets are still a very popular form of computers.
We've seen laptops replace desktop computers to a large degree. Are we going to see tablets replace laptops?
Look, in the new iOS 26, the iPad actually got the ability to have movable windows. It got an arrow for a cursor as opposed to the dot. And the iPad has become more like a Mac than ever before. I mean, Windows laptops or Windows tablets are just running Windows. You also have Android tablets. And in fact, there is an Android for desktop leak that happened recently. So you could see Android becoming an alternative to Chromebooks, which is they can run Android apps, but that's Google's version of a mobile operating system that is more designed for the keyboard and mouse than the typical tablet, although plenty of tablets come with keyboards and mice or the ability to attach a case that has a keyboard and a trackpad in it. I mean, the tablet today is much more versatile than it was when it first launched. And even on the iPad, you can now change the different audio sources. So when you record things, it's more like a Mac, more like a PC. It's more versatile. And I'm sure that Apple is going to have even more advancements with its iPads to come as the iPad and Mac lines merge. I mean, one of the big things that's meant to happen in the next year or two is a touchscreen Mac. Now, if you have a touchscreen Mac, and Macs can already run iPad apps if the iPad app maker allows it to be run on a Mac.
Now, I used to have an HP years and years ago, which was a laptop, and it had a touchscreen on it. And in fact, you could turn the screen around, put it on the back of the keypad part of the laptop, and treat it pretty much like an iPad.
Yeah, look, those Windows tablets still exist. Some of them, the screen will fold all the way back, and the keyboard will be facing the table, and the laptop, the tablet side will be on top. Some of them still have the twisting mechanism. So those haven't gone away. They do come with a stylus, but the thing is they are still Windows computers at heart. And whilst they do have the touchscreen capability, there are plenty of apps in the Microsoft Store. I mean, all the action for apps is happening both in the iPad space and in the Android tablet space, with the iPad space probably the most robust and, app-filled. So Microsoft, although they've had tablets for some time, they're still Windows computers at heart, and that is just one of those things. But we do have the infusion of AI. Lenovo and Motorola, we spoke about that a couple of weeks ago, have this new thing called Kira, which operates across Windows and Android tablets to deliver this more seamless user experience, but it's yet to be launched. And of course, Apple is working with Google to have Gemini underpin the next Siri. And I'm using Gemini to create infographics for stories. You ask Gemini to do various things just by asking. I'm even showing somebody how they can use Gemini to remove remove the background out of a photo just by asking, and then to add certain things in. And I was even using Gemini today. I had a photograph of a couple of friends whose wedding anniversary is today. And I said, make this wedding anniversary video with fireworks in the background. And it did a fabulous job. I mean, just for the asking. If I had to do all that by hand or using some sort of video creation tool, I would not have been able to do it in the 2.5 minutes that it took for that to happen. So the tablet is becoming a large screen window into this AI world where you can just converse with the computer and ask it to do things. And this is a form factor which is more portable than a laptop. It has longer battery life. It doesn't require backups in the traditional sense. It's got iCloud or Google backup. And more people are loving this.
That's Alex Zaharov-Royd from TechAdvice.life, and this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.